We can start. Okay. So, well, I will give just a short introduction on Gaia. Some of you already know her. Well, she's a new member of the team in Frontac Nexus project, and she already participated to other previous projects, in particular in Cities Food with Gertrude, and she will give this presentation on, let's say, general introduction on soilless cultivation systems. So Gaia, please start.
Thank you, Elisa. Good morning, everyone. I'm Gaia. Nice to meet you, everyone. Today I'm going to introduce you some, let's say, information about soilless cultivation systems for vegetable crop production. First of all, I think it's important to quickly underline the difference between a traditional cultivation system and a soilless system. Basically, in a traditional system, so for example, open field, we use soil to grow our plants. That is a composition of sand, clay, and silt, and it contains minerals and organic materials. While in a soilless system, we replace the use of soil with a substrate that is inert, so it doesn't contain any minerals or nutrients. The soilless systems are basically divided in hydroponics and substrate culture, but I would say that substrate culture could be aligned to hydroponic, and we will see it later. So basically, what is hydroponic is soilless technique in which the root system is floating directly to the nutrient solution, or it is supported by inert substrate that is fed regularly by a nutrient solution. Today, hydroponics is diffused around the world, both for what concern high technology soilless cultivation systems and simplified soilless cultivation systems. For what concern high-tech soilless cultivation systems are mainly used for commercial production of vegetables. In this case, we have a standard condition, so of course the technology and the level of technology and of accuracy is higher than a simplified soilless cultivation system, like we can see from this picture. These type of systems are made by reused materials, so available materials that you can find locally and like priceless. And this type of soilless systems are used mainly for self-production in urban and peri-urban areas, mostly in developing countries. Moreover, soilless system can be divided in open loop and closed loop systems. The open loop ones are those systems in which the nutrient solution goes out or get drained, so we can't resave it. Is not recirculating during the system. So in this case, we have a waste of water and nutrients, but at the same time, the nutritional control is easier because at the beginning of the system, we put new solution every time. So we know exactly the amount of nutrient that we are putting inside. While in a closed loop system, we can recirculate and recover the nutrient solution. So in this case, we can save a lot of water and nutrients and reduce pollution at the same time. But in this case, the nutritional management is more difficult because the nutrient solution that is draining is putting in at the beginning of the system. So you have to adjust and control the amount of nutrients inside. Here in this picture, I wanted to show you a little bit a simple hydroponic unit. So what are the features of a hydroponic system? Basically, we have the growing bed. here, in which we put our plants directly to the nutrient solution or supported by a substrate. And then we have, of course, our nutrient solution that is made by water and fertilizers. So we can do it manually, or we can do it by a fertigation system in a high technology environment, like with this fertigation controller. In this case, we create our nutrient solution that is coming inside the system. Here, for example, inside the greenhouse. For that, we need, of course, a pump. Sorry, come back. A water pump in order to recirculate the nutrient solution if we are in a closed loop system, and an air pump to oxygenate the root system. It depends on the type of soilless system that we are using. We will see those types later. Oh, can you see the presentation? Sorry. Okay, yes. Can you see it?
Yes, we can.
Yes, Gaia.
Sorry. Okay, sorry. And to summarize, what are the advantages of a soilless system compared to a traditional system? Why we are choosing this type of technique? Because first of all, we can save a lot of land, water, and nutrient. So the land, water, and nutrient use efficiency is really higher compared to a traditional cultivation system. And we can achieve high yield and constant yield throughout the year, because we are independent from the soil fertility and from the solar radiation, depending if we are working in a controlled environment or not. And then we have, of course, increased freshness, lower food waste, uniform quality, and lower labor needs compared to, for example, basic agronomic operations in open field. Okay, now I will talk about the most popular typologies of soilless systems. First of all, we have the NFT system, is the nutrient field technique. In this type of technique, plants are placed in old tubes in which is flowing the nutrient solution that is creating a film of 1 or 2 millimeters. So the root system is not totally immersed into the nutrient solution, but just partially. And this is let's say high-tech NFT system, but we can have, for example, simplified ones like the Garrafas PET. This type of system is still an NFT, but we have plastic bottles like pots. So here the tubes are the line of bottles in which the nutrient solution is flowing. Here another type of NFT, but the operation is the same. And then we have the floating system. This is a really let's say easy system, because it is characterized by these tanks filled of nutrient solution, in which we put our plants, we let them floating in this nutrient solution, supported by generally a polystyrene tray, like here, like you can see here. And this type of system is mainly used for leafy crops or nursery stock. We can say here as well that the roots are really wide because they are like totally immersed in the nutrient solution. Moreover, we have the hydroponic technique. This is a new technique, and it is characterized by spraying the nutrient solution against the root system. So basically, we have jets inside this panel. There are jets that that can spray the nutrient solution, so we can save a lot of water and nutrients. And like here you can see the jets inside these structures, but it's not always a I don't know, trellis structure, but can be horizontal as well. It depends on the how the system is built. And another one is a deep water culture. It's still an easy technique, because we just have this pot in which we put the nutrient solution, and we immerse the plant inside the nutrient solution, supported by a substrate. You can see it here, sorry, to support the root system. This type of system need an air pump in order to oxygenate the root system, because the nutrient solution just stay there. So we need to oxygenate the roots, and it is suitable mostly for ornamental plants with slow growth. Sorry. And finally, we have the substrate cultures, like I mentioned before. In this type of system, the plants are placed in a substrate that has the function of support and water and nutrient retention. So it allows a better uptake of nutrient and water. And of course, the substrate it is fed by a fertigation system, so a nutrient solution. Here we can see it better. So we have the bag with a substrate inside. We put the plants inside, and then we have the fertigation system in order to supply water and nutrients. Here another example with bags, proper bags. And again, this is a technique that I want to mention, because it is really it's performing really good. And the ebb and flow system is characterized by two phases: flood and drain. So the first phase is the flooding, when the water and nutrients flow the growing areas, supplying water and nutrients. And then we have the second phase, that is the draining phase, in which the water and the nutrient solution goes back to the reservoir. Like with this periodical nutritional control, we can enhance the production performance. Now, I want to talk a little bit about substrate. The substrate main function is to support the plants while allowing a uniform flow of nutrient solution. And the substrate that we are choosing for our system, it has to have some specific feature, like good water and drainage retention capacity, and high degradation resistance, so high durability during the time. In this case, like for example, if a material is more durable, we can save money during the year and make, like, let's say, less waste. And it doesn't have to contain any macro and microorganism, any mineral or nutrients, and it has to be easy transportable and possibly available in the local context. The substrate can be divided in inorganic or organic. The inorganic ones have natural origin, but they are obtained from rocks and minerals. And they can be natural unmodified materials like sand, tuff, or pumice, or they can be processed materials, so they undergo like simple treatment and processes. and they are perlite, vermiculite, zeolite, etc. This type of substrate are characterized by an high porosity, so an high drainage capacity. So we have to be careful about it, and maybe do a mix with the organic material that are produced by biological composition. In this case, like for example, we have biochar, coconut fiber, wood fiber, rice hulls, and yeah, this type of substrate can be high, can have high contents in organic matter and nutrients, so we have to be careful about that. But they perform very well. Here, a little focus on the parameters that we have to check in our hydroponic system. First of all, we talk about the nutrient solution parameters. So what we have to check and control, what's important to control in our nutrient solution. The main features are pH, electrical conductivity, and temperature. The pH, it's important to allow a better uptake of nutrients and water by plants. And the range that is suggested generally is between 4.5 and 5.5. While the electrical conductivity doesn't have an optimal value in general, because it depends from crop to crop, and it is correlated to the presence of salt and so nutrients inside the nutrient solution. So we have to check what is the optimal value for the crops that we are cultivating, and then adjust the electrical conductivity value based on that. And finally, we have the temperature that is still really important in order to better uptake the nutrients. And the suggested range is between 18 and 22 Celsius degrees. For what concern controlled environment, so if we are working in a controlled environment, of course, the parameters to check are more and different. We are talking about light and climate. For example, for light, it depends on if we are working with artificial lighting or solar radiation. And in order to improve our performance, we can control and adjust the light spectrum, the photo period, and the light intensity. Of course, the management of this feature would be different depending on if we have artificial lighting or if we use solar radiation as light source. Because, for example, if we want to decrease the intensity of radiation in a typical greenhouse, we can use whitewashing, we can use shading. While if we are using an artificial lighting, we can just control and adjust the parameter in our lighting system. For the climate is the same. The most important parameters that has to be controlled are temperature, relative humidity, and CO2. And in this case, again, the control would be different if we are working in a low-tech condition or in a high-tech condition. Like here, we can say the different facilities. Here, a typical greenhouse. Here we have a vertical farm. Oops. Sorry, this presentation is not the right one, but okay. Here we can see some of the instruments in order to check. For example, here the EC meter, pH meters. This type of instrument are like we can find different type of these instruments, but the operation is the same. probes, and yeah, other instruments. I'm sorry, but I have to go back. Presentation. Okay, talking about light, I wanted to do a focus on artificial lighting, because if we are working with artificial lighting, we can change the spectra of our light. So we can work with white light, but even blue, green, or red light. But knowing that the chlorophyll absorbs the light mostly in the red and blue wavelength, we know that playing and using the differentiation of blue and red, we can enhance the performance, the vegetative growth and production of our crop. And it has been suggested that a ratio between red and blue light of 3:1 is show the better performance in production and vegetative growth in most of the crops. And to conclude, I want to just remind you what are the activities that we have to do every day in order to let our system perform well. The daily activities are basically check if the drippers of our fertigation system or irrigation system are working well, or they are whether they are obstructed or not. Check if the water is flowing and if there are leaks in our system. Check the water temperature and level, and check the electroconductivity, the pH, and the temperature. Every day is better, but we can do it twice or 3 times per week. Check if the plants check the plants for pests, like if there are some disease, or remove any sick organ or plants. And then we have weekly activities that are control pH, temperature, and of course adjust it if necessary. Look for deficiencies, understand what is what the plants what is lacking, and add fertilizers if necessary, and then plant and harvest what is required. So the plant that has to be harvested and replaced, and check for obstruction of pipes and drippers again. And this is all. It's just a quick introduction for Soilless systems, and I hope it has been useful for you. Thank you for your attention.
Thank you very much, Gaia. So I think we have time for questions now, if there is any question.
Yeah, I do have a question. Thank you, Gaia, for this presentation. It's good. You mentioned something about the substrate, and you said something about the biochar, but it's well known that biochar will affect the seedling for some crops, and it will start to accumulate in the roots, and that will, let's say, halt the growth or disturb the growth of the seedlings. How can you just elaborate on that? And the second thing, all of the routine activities can be monitored online through dashboard, and you can even control with the system from outside the farm. I have a friend of mine here in Jordan. He has a control system at his place, and I can share with you guys the dashboard of what he is doing, if you guys allow me.
Yes, he has remote control of sensors, right?
Not only temperature. I just will share it with you. CO2 for the humidity, the air temperature, AC, water temperature, tank level, the O meter, and the pH. And you can adjust all of these. You change the parameters. Like let's say that you want the EC of your system is 700. He has like special algorithm into the system. Maybe we can invite him to the dissemination that we will do at NARC if that is possible.
Yeah, that's a really good thing because it's a, let's say, advanced management of the system, because you can adjust and control it remotely. And of course, you can do that. It depends on the level of technology of your company or, I don't know, facility. So yeah, of course, you can control it from devices and yeah, like instead of manually, of course, would be better. I didn't mention it, but yes, it is possible, of course, control all the parameters remotely by a phone, with a phone, or I don't know, a laptop. And sorry, what concern by
the biochar as a substrate?
Yes. Yeah. What did you? Sorry, I didn't catch it.
Yeah, I mean, biochar known to affect seedling in the hydroponic system, and it will accumulate on the roots, and that will just like hinder the growth of the plant.
I would say it depends, but you can, basically, you can mix an organic substrate with an inorganic substrate in order to enhance the performance of drainage and retention capacity. But yeah, I would say it depends on the crop. Like affect the seedlings in what sense? Like affect the seedlings?
The question was how the biochar affects the seedlings.
What, sorry?
Amer, the question was how biochar affects the seedlings, but you are muted.
Yeah.
Amer, you're muted. We cannot hear you.
Sorry. I was reading a paper the other day that biochar affect the seedling of, for instance, wheat or rice in some countries. In and most of these plants are growing in a hydroponic system and in soilless culture. And they found out that the biochar starts to accumulate in the root system, and that's change the condition around the root system. Instead of the system will get like nutrient solution, and the biochar, because it's negatively charged, will start accumulating on the surface of the roots. So this is my question.
Okay.
I mean,
yeah, honestly, I don't know, because I'm not working on herbaceous, so I just know about vegetable crops. So maize, I don't know. Honestly, Elisa, you know something about this
actually,
problem? Because
no, actually I don't know neither, but well, could be possible if if it has been evaluated in a scientific research, of course. But yeah, in general, integration of organic materials could be useful, and of course, the integration depends on the kind of system we are using. Of course, we will not use this kind of organic substrates if we are in an aeroponic system or in a floating system, for instance. If we are using pots, like in an ebb and flow system, we can integrate. And for some crops, biochar could be a useful stimulant.
So Amma, maybe you can share the DOI.
Yeah, I will share the article. It's a recent article from 2024, and I will share it with you guys. I will just how to do it here.
Maybe
Amma, do you have access to the chat? Sorry, because I'm not sure if you can share the documents.
Yeah, no, I don't have access actually.
Okay.
Amma, maybe you could share it in the WhatsApp group.
Yeah, sure, no problem. Second.
Yeah, but I used personally biochar with lettuce and it performed very well. So I don't know. I think it could be depending on the crop that you are using.
You know that this is problematic. I applied for a grant to get a project in the hydroponic system, and our focus was to use biochar as a solution in terms of growth and mixing with other material. And one of the comments that we got from the committee that trying to, let's say, criticize our work is biochar is not recommended in hydroponic in general. And this was my concern, you know.
Yeah, okay.
I just shared the paper on the WhatsApp group. If you have access to it, so you can just read it and.
Okay, guys, I'm sorry. My presentation wasn't the right one. I don't know why, but I will. Maybe Elisa will share with you the right one. There are more like pictures that can be useful for you, like nothing special, but maybe would be better. And
sure. Yeah, we
can I
will
close
share.
it?
We will share all the documents and also this recording. Are there any other questions?
Yes, Sema wrote on the chat, any infos on strawberries in hydroponics?
Okay. On strawberries, yeah. Yeah.
Yeah, info like what, like how they perform, or like usually how they perform is Mini, or in general?
It wasn't my question. It was Sema's. I'm waiting. Maybe he will write something else in the chat.
Sorry.
No, it's okay.
I can say that you can produce, you can have a production with strawberries in hydroponics. So it basically it is possible to grow strawberries. And I didn't work specifically on strawberries, so I don't know the specific, but of course it is possible. And I saw a lot of hydroponic strawberries in a substrate culture. So the plants supported by a substrate and is better than, for example, a floating system. I don't know if you remember, I mentioned this floating system that is the tank fill of nutrient solution. In this case, is not so good for the strawberries, because the roots are not really the oxygenation has to be really good, and there's no a proper substrate to support the plant, because the strawberry is a quite like big plant, not so big, but an important root system. So I would suggest to cultivate it on a substrate culture. But I don't know who is the question. So
Osama, but I think he's not here right now. And then, well, I just want to mention one thing, that in the next workshops, we will also have a more specific focus on specific crops. So stay tuned. I think, are there any other questions?
Not now.
Not now. Okay. So I think that we are perfectly on time. Thank you very much, Gaia. I think we can close the meeting here.